So let's go to the final part of De Moivre's theorem, which is the power and also the roots of complex number. For the power of complex number, first make sure you are in polar form first, and then if you want to take the power of n, this is very easy. For r outside here, we just follow the state power of n, and the form inside will be cos something plus I sine something, the same thing here. However, you need to do a bit of adjustment. For your angle theta, you need to multiply n, and your n here must be more than 0. And the argument n theta is considered within the range of 0 until 2 pi. What happens if you have more? For example, you have 390 degree. This is more than 2 pi, more than 360 degree. So now you use coterminal angle. What is it? This is just open up the quadrant here. You can see that coterminal angle will cover if the angle is more than one cycle. So 390 degree is just 360 degree. Plus another 30 degree angle. So the coterminal angle will convert from 390, your angle will just be 30 degree. Make sure if you have more than one cycle, you convert using coterminal angle. So now let's see example 4, how to do 7th power of the complex number. So let's follow the formula. Okay, first this is already in polar form, so very easy. So now let's take z power of 7. Your r outside here will just follow 2 to the power of 7, and inside here cos something plus I sine something. The form is the same. Let's do adjustment to our angle here. 45 degree, we need to multiply with n multiply 7. Okay, so 7 times 45 degree. This is also 7 times 45 degree. This is just 315 degree. So that's it. This is your answer in polar form. If you want to leave your answer in standard form, you can just solve. Okay, and finally insert 1 to 8 inside. So this is your answer, 64 sec 2 minus 64 sec 2i. So this is how to do De Moivre's theorem for the power rule. If you want to take the roots of complex number, your r outside will just follow. Okay, if you want to take root n, so outside here is root n of r, and the form of inside is the same, cos something plus I sine something. Okay, then let's focus towards our angle inside. Okay, now let's see what happened here. Your theta will be divided with n. Okay, if you see here, theta is divided with n, and we just plus with 2 pi k both of the angle. Why? Because we want to follow cycle, so we just add plus 2 pi k for the periodic property. Your k will take the value of 0, 1, 2, 3 and so on, and we will stop at the value of n minus 1. Now let me show you how to do this in example 5. This is the question, and they ask you to find the square root. Okay, for square root, your n is 2, right? Okay, so let's do this. Square root of z is equal to square root of 9, because your r outside will just follow. Now for the inside value, the form will be the same, cos something plus I sine something. Now let's work out on your angle. Okay, your angle will be 60 degree, divide with your n. Your n now is 2, so divide with 2. Don't forget to plus 360 degree k. So the value of here will also follow like this. And your k will starting from 0, 1 and so on, and we stop at n minus 1. So 2 minus 1 is 1, so our k will stop at 0 and 1. Now let's solve this. 9 is 3, so we can read our answer WK as z is equal to 3, and in bracket here is cos 30 degree plus 180 degree k, and another one is I sine 30 degree plus 180 degree k. So you can rewrite our equation like this. So this is your general formula for your answer of De Moivre's theorem. Now let's take your answer for W0. Okay, just put your K as 0. Therefore, your answer is 3 cos 30 degree plus I sine 30 degree. This is your answer in polar form. If you want to solve this in standard form, you can just solve for cos 30 degree and sine 30 degrees. So your answer will be 3 in bracket set 3 over 2 plus 1 over 2I. Okay, so now let's fill in our 3 inside. So now let's expand 3 inside. Your answer will be 3 set 3 over 2 plus 3 over 2I. Now let's find your answer when your K is equal to 1. For W1, your K is equal to 1. So let's put in our value 3 in bracket cos 30 degree plus 180 degree plus I sine 30 degree plus 180 degree. Therefore, your answer will be 3 cos 210 degree plus I sine. So if you ask for polar form, this is your answer. However, if you want to give standard form, you need to open up this value here. So let's open up. Your answer will be 3 in bracket is minus 3 over 2 minus 1 over 2I. Therefore, to find out the final answer, let's expand everything. So your answer will be minus 3 set 3 over 2 minus 3 over 2I. Therefore, that is your final answer. So that's all for the Moivre's theorem. Assalamualaikum warahmatullahi wabarakatuh.